Hi, so in this video we're going to be working with the polygon angle sum theorem, right? That says that the sum of the measure of the interior angles of an n-gon, that means that it has n sides, is n minus 2 times 180. So from this one I can divide, all right, my next one. Right, an equilateral polygon is one that has all its sides congruent, and an equilateral polygon, equiangular polygon, is one that has all its angles congruent, right? And one that has both of them is a regular polygon. So again, a regular polygon is one that has both equilateral and equiangular congruent, right? It's both equiangular and equilateral. Right? The corollary to the polygon angle sum theorem states that if a polygon is regular, then I can find the measure of each angle by multiplying n minus 2 180 divided by n, right? To be a regular polygon, again, all the angle has to be exactly the same, so I just divide on how many angles, right? So let's see those theorems in a couple of exercises. My next one is the polygon exterior angle theorem, right? So the measure of the exterior angle of a polygon, one at each vertex, is 360, right? And the last one, right? If it's a polygon, then I'm just going to divide 360 by that polygon to find how much is the angles, right? So, but before that, I need to go back and go over to the definitions that I think that we have on Unit 9. And it's convex and concave polygons, right? So in this case, a concave convex polygon has no diagonals with points outside of the polygon, right? So if I draw my diagonals from right here and to wherever I want to draw them, as you can see, none of them are going out. Right? Remember that diagonal is a segment that has endpoints in two non-consecutive vertex, right? In this case, for example, on this one, a concave has, as you can see, this one has an interior. Another way of seeing it is that part of the figure is like coining, right? So if I continue those two lines, they're going to have points in the interior of the polygon. Okay, so that's right. So my first one, start with this one. So this one, I'm going to state if it's convex or concave. As you can see, if I can draw all my diagonals, all of them are going to be completely in the interior of the triad of the polygon. So in this case, this is convex. Convex. The second one, in this case, as you can see, this one, if I draw this diagonal here, right, is in the exterior. So this is concave. Concave. The next one, again, if I draw this diagonal here, this is concave, and it's going also in, right? As you can see right here, right? It is going in, right? Now, we want to find the exterior angles, the interior angle of each polygon, right? So in this case, it says that it's a regular hexagon. As you can see, hexagon has 6 sides. So that means that I'm going to use let's name it that S equals 6 minus 2 times 180. So 4 times 180 equals 120 degrees. The next one, I have a regular 14. Right, so n is 14. So in this case, I have that. It's 14 minus 2 times 180. So 12 times 180. So 12 times 180 is equals 2160. Right? That's a sum of all the interior angles, right? If I want to find exactly one angle, I'm just dividing 160, that 2160 by 14. So that means that this is approximately 154 with 29 degrees, 0.29 degrees. Again, regular 16. So this is 16 minus 2 times 180. So 14 times 180. 14 times 180 is 2520. Okay. Each angle, 2520 divided by 16. So divided by 16, that's 157.5 degrees. Next exercise, find the measure of one interior angle in each regular polygon. So, and I want to find one interior angle. So that means an hexagon. Again, it's 6, so n is 6. So I have 6 minus 2 times 180 divided by 6. So I have 4 times 180 divided by 6. That's 720 divided by 6. So that's 120 degrees. So each angle of that regular hexagon is 120. Regular quadrilateral. This one is pretty easy. We're going to use the formula. So 4 minus 2 times 80 divided by 4. So 4 times 180, or 2 divided, 2 times 180, 2 times 180 divided by 4, and that's 90 degrees. Find the measure of one exterior angle of each regular polygon, right? So now we're working with exterior. So this, remember that the sum of all the exterior angles is 360. So I have 360 divided by 7. 360 divided by 7. That is 51.4 degrees. Next one, regular 17. So that means that is 360 divided by 17. So 360 divided by 17, that's 21.2 degrees. Now I want to find the measure of y. Right, so my first step I have to find the measure of how much is the interior angle. So I have 1, 2, 3, 4, 5, 6 sides. So that means that this is 6 minus 2 times 180. So 4 times 180, 720. Now, if I add 2y minus 20, as you can see, 2y minus 20 is here. 1, 2, 3, 4 angles measure the same. So I can multiply this times 4. Plus y and y, so 2y equals 720. Again, this angle, that angle, this one and this one equals 2y minus 20. So that means that I can multiply that times 4. So 8y minus 80 plus 2y equals 720. So 10y minus 80, 720. So plus 80 plus 80, 10y equals 800. And now I'm going to divide by 10. So y equals 80. Last one again. Let's count those sides. Let's mark them. So let's say 1, 2, 3, 4, 5, 6, 7 sides, right? So I have 7 sides. So 7 minus 2 times 180. So 5 times 180. 5 times 180, that's 900. So again, I have this angle, that angle, and this one. And this one is x plus 50. So I have that is 4 times x plus 50 plus 3 times x, right? Because I have 1, 2, and 3x. Okay, so equals 900. So this is 4x plus 200 plus 3x. And also 7x plus 200. Minus 200. 7x equals 700. X equals 100.
That's it for this lesson. May the force be with you.